meaningful solutions when we had complex conjugate solution.
Cosine x and sine x.
Yeah, it ended up being cosine x and sine x. Do you remember what I used?
It's alpha plus minus beta I.
Yeah, I
Alpha
used
cosine
the,
x.
Imaginary plane, circle.
yeah, the Euler's equation. Remember? I'll write it again.
A lot of things to remember.
You don't need to know Euler's equation.
Okay.
It's a very important equation, but you don't need to know it.
So I'm not very important.
What?
So I'm not very important.
You're not very important?
It's a very important equation. Like I don't need to remember because it's not VIP.
Not in real life. But in math, it's a very
Okay.
important equation.
You can memorize.
You're never going to use it. You're never going to use it, but it's a very important equation.
Just like that.
What is it used for? Well, never mind. I'll find out in a second.
What?
You said what we use it for, but never mind. I'll find out in a second.
For things like this.
Yeah, I think
For
that's
interpreting complex exponents. So, whenever you run into complex exponents in real life, then you know what to do. All right, so. Okay, so it says that e to the I theta is equal to cosine theta plus I sine theta. Okay, so this is for a purely imaginary exponent. Right, if you have a complex exponent, then you can split the exponential into the real part and the imaginary part. Okay, so again, I'll do this one time, and then from now on, you can use this catalog to write the solutions. Okay, so this next equation happens to have two complex solutions. Okay, so same substitution. Okay, so what will the first term be? After substituting.
squared.
M minus one, x, m. Okay. Second term after substituting will be 5 times m times x to the n.
Oh, 5x, right?
5x, well, the x multiplied by the x m
Oh, okay.
minus 1 gives us x to the n. It's 5 m x to the n. Okay, and then the last term is 13 x to the n. Okay, so then divide by this common factor of x to the n, and that gives us m squared minus n plus 5n plus 4n plus 13 equals 0. Okay, so if you want to use the quadratic formula, this is probably easier, more easily done with completing the square.
Half Q and
So that's 25 minus,
Is it
There.
16 minus 4?
oh, 16, yeah, I looked at the wrong. Okay, so 16 minus 52, negative 36, right? Square root of negative 36 is
6x.
6x. Okay, so it's negative 2 plus or minus 3x. Okay, so this gives us two distinct solutions, right? So we had two linearly independent solutions to the equation. Okay, so last time it was a bit easier to use this formula because the base was already E. Anyone know how to change the base from X to E?
Change base formula.
What? No.
You tell me. Change base formula?
That's for logarithms.
Okay.
It's related to that though.
Got his cousin.
Grasping at straws at this point.
So I'm saying X is equal to E and then what else? E log X, right? Okay, so, alright, so bear with me, I'd rather not just say, and these are the solutions, okay? But after this, you can appeal to whatever the solution, the form of the solution is. Okay, so the general solution is C1, x to the minus 2 plus 3i, C2, x to the minus 2 minus 3i. Okay, so let's change x to base E by writing it as E to the log x. Okay, so the exponent is this multiplied by this. Okay, so like before, let's split this into the real part and the imaginary part. Okay, so that I don't have to rewrite, let me write it this way. So I can split the sum by multiplying the base. Okay, and then same thing here. Split this by multiplying the base. See? Okay, so there's a common factor of e to the minus 2 log x. Okay, so what is theta for the first? 3i log x. Euler's formula theta is what? Everything but the I, right? 3 log x.
3 log x.
Okay.
It's too simple. Okay, so let's use Euler's formula. Okay, so recognizing that this is 3 log x in the formula, then this is cosine 3 log x plus I sine 3 log x. Okay, and then second, here theta in the formula is minus 3 log x. All right. So how are these related? cosine 3 log x versus cosine minus 3 log x.
Cancels.
They don't cancel. Cosine's an even function, so it absorbs negative signs, right? So cosine of 3 log x is the same as cosine minus 3 log x. Okay, so these are the same. Okay. These are related. This is an odd function, so the minus sign comes out, right? So these are opposite. Okay, so let me skip over some stuff, right? So what do? We write this is the same, we write this is negative, right? And then combine the coefficients, rename the coefficients, all together, it equals this. Okay, so C1, new C1, let me write it like this. New C1 cosine 3 log x. Okay, new C2 of sine multiplied by sine 3 log x. Okay, and then one last thing to notice, right, so we can rewrite this. If we bring this up as an exponent, this becomes what? X minus 2. Right, so altogether, it's C1 x minus 2 cosine 3 log x. C2 x to the minus 2 sine of 3 log x. Okay, so now let's back up. So where did all of this come from? These were the two solutions. Right, so if you have complex solutions, then what? The real part, exponent of x, right? The real part is minus 2. Right? The imaginary part, plus or minus 3i. The 3 is the coefficient of log x within sine and cosine. Okay, so very similar to equations with constant coefficients. What was it with equations of constant coefficients? The real part was what? I told you the...
There was the coefficient of the e to the x.
So the real part tells you the exponential, right? Because that was the assumption, that it was some sort of exponential. The imaginary part contributed sine and cosine. Okay, so it's more or less the same. Instead of an exponential, it's a power of x, right? Instead of just sine and cosine, the argument of sine and cosine also contains log x. Okay, so now on, you can appeal to these different solutions. Okay, so if you have distinct, you have strictly powers of x. If you have repeated, then what? You have the power of x, and then for the additional solutions, you do what?
Multiply
by
x.
log x.
Log x. Log x.
And then if you have complex solutions, you have a power of x multiplied by sine and cosine, evaluated at log x. All right. So why don't you all try the 3 problems